Welcome everyone. Heat waves provide the perfect optics for those who want to push climate alarmism, arguing that CO2 is causing the world to dramatically overheat. But using uncontested physics and published peer-reviewed evidence, I will conclusively show that heat waves are all natural. So today in part 5 of how pressure systems control the climate, I examine how natural shifts in the location and duration of high pressure systems are what cause heat waves. Now, various researchers define heat waves differently depending on the hypotheses they want to support. But the American Meteorological Organization defines a heat wave as a weather event during which maximum temperatures are 5+ degrees Celsius higher than the average on those dates and lasts for 5+ consecutive days. The researchers that push a CO2-driven climate crisis argue that it is the shift in the average global temperature that results in more extreme heat waves and more record-high temperatures. But that is misinformation. Any honest and critical thinker will readily see that the peak in USA heat waves, as illustrated by the EPA, happened in the 1930s, and there is no correlation with the global warming trend. Clearly, heat waves and extreme temperatures are caused by factors other than changes in the global average temperature statistic. Such a false manufactured statistical argument is why Mark Twain's quip that there are lies, damn lies, and statistics has resonated for over a century. To put heat waves and extreme temperatures into perspective, we first see that the theoretical maximum ground surface temperature has been estimated to lie between 90 and 100 degrees Celsius or 194 to 212 Fahrenheit. The air temperatures used to generate a global average are primarily heated by contact with the Earth's solar heated surfaces. Air temperatures correlate with ground temperatures but are 30 to 50 degrees Celsius cooler. Based on that difference, we can infer the theoretical maximum air temperature should lie between 50 and 60 degrees Celsius or 122 to 140 Fahrenheit. The science of heat waves and maximum temperatures have determined 5 basic factors to evaluate any warming trends. First, maximum temperatures are determined by overhead angle of sunlight, which is greatest in the tropics. Clear skies permit maximum insolation, but are greatest in the subtropics under high pressure systems. Second, because air is heated by contact with the ground, changes in surface conditions are very important. Dry surfaces heat to much higher temperatures than moist surfaces, without any added solar or greenhouse heating. Third, temperatures in descending air currents also increase temperature without any added heated energy due to increasing pressure, as witnessed under high pressure systems and Foehn winds. Fourth, changes in mixing can also increase air temperatures without any added solar or greenhouse heating. For example, warm air was transported from the Sahara Desert and raised temperatures during Europe's heat waves. Finally, there is the balance between radiative heating and radiative cooling. Climate crisis narratives suggest increased CO2 slows the escape of infrared heat energy, reducing the rate of cooling and thus causing warming. But counterintuitively, outgoing infrared heat energy increases during heat waves due to the dry conditions beneath high pressure systems and thus reduce any greenhouse effect. The most intense solar heating happens in the tropics and the least in the polar regions. The direct rays of the sun are overhead and concentrated during the northern hemisphere summer, shifting as far north as 23.5 degrees, and then traveling to the south at 23.5 degrees for the southern hemisphere summer. This swath of latitudinal heating from the most intense sunlight defines the tropics, but due to cloudiness, the Earth's most extreme temperatures don't happen in the tropics. North America's, and also the world's record for the hottest extreme temperature ever measured, is 56.6 Celsius or 134 Fahrenheit, measured in Death Valley, California, located in the subtropics at 30 degrees north, on July 10, 1913. This century-old record again refutes any correlation with global average warming trends. It is likely this record has not been broken because it lies close to the theoretical maximum caused by the combined dynamics previously outlined. Africa's record maximum is 55 degrees Celsius, or 131 Fahrenheit, done on July 7, 1931, in Tunisia, located 32 degrees north. Asia's record maximum of 54 degrees Celsius, or 129.2 Fahrenheit, happened in Israel on June 21, 1942, at 32 degrees north. These extreme temperatures all happen within weeks of the summer solstice, during a colder global average temperature, and in the subtropics where dry desert conditions and cloudless high-pressure systems prevail. Europe's record maximum happened in Athens, Greece, on July 1977. In Australia's record of 50.7 Celsius or 123 Fahrenheit happened in January 1960 in Unadada, Australia, that claims to be the driest town in the driest state of the driest continent. Science clearly explains the contributions of dryness to extreme temperatures. Dry soil requires 0.8 of a joule of energy to raise a gram of dry soil by 1 degree. In contrast, wet soil requires more than twice that energy to raise a gram by 1 degree. In addition, over 2,200 joules are required to evaporate a gram of water without raising its temperature, causing evaporative cooling. Without adding any heat energy from the sun or greenhouse gases, increasing dryness raises local temperatures, again illustrating why temperature change is not a reliable indicator of increased greenhouse warming. The much higher temperatures measured in big cities is called the urban heat island effect, which amplifies the public suffering during a heat wave. The urban heat island effect is caused in part by the drying of the landscape, as rains are quickly diverted into storm sewers instead of moistening the ground. In addition, the landscape is increasingly covered in asphalt and concrete, which takes less energy to heat and holds that heat much longer. Those who push a climate crisis often use this graph of warming temperatures in the USA's 50 largest cities from climate.gov. But to claim that warming trend is due to rising CO2 is misinformation that ignores the increasing drying effects. Foehn winds are another example of higher temperatures that are not caused by added solar or greenhouse warming, but warm adiabatically solely due to increasing air pressure. Moist air approaching the mountains are forced upwards on the windward side. They release the latent heat from condensing water vapor and helps the air to rise. On the leeward side, as the air descends, it warms to several degrees warmer than it had been on the windward side, solely due to increasing pressure. The record temperature of 18.3 Celsius or 64.9 Fahrenheit for Antarctica happened on February 6, 2020, and much to the delight of the CO2 climate crisis crowd. But this record was caused by a Foehn wind descending on the Esperanza Base, which is located at the tip of the Antarctic Peninsula, the continent's most equatorward location. Depending on the strength and attack angle of the westerly winds, The winds will travel around the peninsula or at other times go up and over the peninsula's mountains. The Antarctic record temperature was simply an example of natural adiabatic heating from a Foehn wind. Now, high-pressure systems are created by dry descending air currents that also heat the air adiabatically, the same as Foehn winds. High-pressure systems are almost always associated with a heat wave. The dry descending air creates clear skies that allow more solar heating. In addition, the adiabatically warm descending air prevents warm surface air from rising and mixing with cooler air, creating a heat dome, analogous to the heating of a car with its windows rolled up. With the age of satellites, we can now measure changes in outgoing long-wave radiation, while surface weather stations can measure the incoming solar radiation at the surface. As illustrated here, during a heat wave in China, the yellow to red colors represent increased downward solar radiation and increased outgoing long-wave radiation measured in watts per meter squared. And a watt is equal to 1 joule of energy per second. Compared to about just 2 watts per meter squared of CO2 downward heat, the center of this heat wave here exhibited 30 to 40 outgoing watts per meter squared, suggesting that there was a decreased greenhouse effect during the heat wave due to drier air. In fact, scientists using satellite data look for such increases in outgoing infrared to determine the location, intensity, and the extent of heat waves around the world. The heating around the equator causes rising air that draws in moisture on the trade winds that converge and then force air upwards, forming the Intertropical Convergence Zone, or ITCZ. Prevented from rising higher at the tropopause, the winds are now redirected towards the poles. Those high-altitude winds converge with equatorward winds, forcing the air down to the ground. This creates a quasi-permanent band of high-pressure systems around the globe centered at about 30 degrees from the equator. Upon reaching the ground, descending air is now redirected, some moving back towards the equator, and due to the Coriolis effect, form the trade winds and complete the circulation cell known as the Hadley cell. I suggest seeing part 2 of this series for a discussion of how the Hadley cell creates the world's rainforests and deserts. Other wind currents are directed northward, and due to the Coriolis effect, form the westerly winds. Where these winds converge with winds from the North Pole, the air is forced upwards again, forming regions of low pressure. The dynamic of converging winds forming high and low pressure systems can be thought of as a short wave train. Furthermore, these regions form the major jet streams that modify the locations of these pressure systems. In 2003, 2010, and 2018, Europe experienced heat waves that broke many local temperature records. All were triggered by drought and high-pressure systems. According to a peer-reviewed paper analyzing the contributing factors by Black 2006, they also found a regional intensified ITCZ for the 2003 heat wave. Here, the northward ITCZ is represented in green as reduced outgoing heat waves. That shifted high-pressure systems further north, illustrated here in red, representing increased outgoing heat waves. In addition, both Black and Sparnocchia 2006 reported hot, dry air was pumped into Western Europe from the Sahara. Now, El Niños and La Niñas can shift the location of intense convection of the ITCZ. During a La Niña, intense convection is located over the western Pacific warm pool, which induces a wave train of sinking air in high pressure over Africa and also over the eastern Pacific, which then induces a low pressure in rain over the Atlantic as seen here. I also suggest seeing part 4 discussing how La Niñas increase the strength of the warm pool and cause global warming. Intense La Niña convection further triggers a wave train of high and low pressure systems that stretches across the Atlantic into Europe and Asia. A map of anomalously wet and dry weather across the globe during a La Niña demonstrates its dominant global teleconnections. It was a La Niña wave train that brought dry weather over the USA's Great Plains, and with that dryness further amplified by landscape degradation, generated the Dust Bowl and the USA's period of greatest heat waves. During an El Nino, the warm water and center of intense convection moves eastward. Sometimes it reaches all the way to the coast of the Americas, and sometimes reaches only to the central Pacific. This induces varying wave trains, with a high pressure over Indonesia causing reduced Asian monsoons and drought. The 1997 and 98 El Nino brought floods to California, but simultaneously extreme drought and deadly heat waves to Indonesia. Scientists have also determined that since the 1960s, they have recorded El Nino events that have amplified heat waves across China. El Nino wave trains also trigger anomalously wet and dry regions around the world, but in different regions than La Nina and neutral years. As Chase 2006 and other scientists have come to realize, natural variability in the form of El Nino and volcanic eruptions is of much greater importance for causing extreme regional temperature anomalies than a simple upward warming trend in time. Now, the Madden-Julian Oscillation begins with an intense convection over the western Indian Ocean warm pool that induces descending air in a high pressure further to the east. Then, over the course of 60 to 90 days, the low and high pressure systems move in tandem across the Pacific until it reaches the cooler waters upwelled in the eastern Pacific. The Madden-Julian Oscillation likewise creates wave trains, such as the one causing high pressure and a heat wave over the coast of South America. The interaction of these varying wave trains makes for complex weather patterns across the world. Poleward wave trains from El Ninos, La Niñas, and the Madden-Julian Oscillation will affect the Arctic Oscillation, during which the polar jet stream shifts from strong west to east zonal flow in its positive phase, then switching to a more wavy flow in its negative phase. Complex interactions with multiple wave trains affects the Arctic Oscillation, causing its phases to switch from month to month. Such monthly phase changes is evidence of natural variability that refutes theories arguing that the wavy jet stream is driven by less Arctic ice in a climate change warming trend. During February 2021's Valentine's Week, a wavy flow brought cold Arctic air southward and deep into the heart of Texas, causing a deep freeze and major societal disruptions. Just months earlier, in June of 2020, a very strong zonal flow of the positive phase prevented cold Arctic air from moving south, which would normally moderate the summer temperatures around the Arctic Circle. Accordingly, on June 20th, 2020, Verkhoyansk, Russia, just north of the Arctic Circle, reached its all-time maximum temperature record of 38 degrees Celsius or 100.4 Fahrenheit, to also become the hottest recorded temperature inside the Arctic Circle. Overland 2020 rightfully concluded This Siberian heat wave in extreme temperature was an example of random weather events. But despite contradictory evidence, Overland also dutifully suggested climate change and Arctic amplification had made the heat wave much worse. Overland ignored that for 30 years prior to this extreme weather event, Verkhoyansk's June temperatures demonstrated a cooling trend. Furthermore, the previous record high temperature deeper inside the Arctic Circle was just 0.2 degrees Celsius cooler, measuring 37.8 degrees Celsius, or 0.4 degrees Fahrenheit cooler at an even 100 Fahrenheit, and set in 1915 at Fort Yukon, Alaska. Just a 0.2 degree increase over 100 years is in reality evidence of an extremely small long-term warming trend due to any Arctic amplification in global warming. And given how sparsely populated it is inside the Arctic Circle, it is highly likely many other Arctic regions have also experienced similar warm temperatures due to the Arctic Oscillations jet stream barrier that prevents the southward flows of cold air. Temperatures that were simply not recorded. Nonetheless, the UN News, in support of its IPCC's climate crisis narrative, characterized this weather event as disturbing high temperature record. So be scared, people. The North Atlantic Oscillation is the regional expression of the Arctic Oscillation and similarly bounces between a wavy jet stream in its negative phase and a strong west to east zonal wind in its positive phase, varying from month to month. And again, it's a measure of natural weather variability independent of climate change, but causing climate-related changes. As published by MISAC in 1990, interactions between El Nino and the jet stream increased the waviness and caused sea ice to expand in Baffin Bay to the west of Greenland, where the jet's southward flow brought colder air and simultaneously causing sea ice reduction to the east of Greenland caused by the jet's northward flow of warmer air. Wavy jet streams also slow down the west to east migration of storms and high pressure systems that are typically observed in daily weather patterns. That enables blocking high pressure systems to sit over a given region for weeks, causing long-term heat waves. A blocking high pressure system enabled the lengthy 2010 Russian heat wave. And a blocking high pressure system enabled the 2019 European heat wave. Now, looking at northern hemisphere temperature anomalies during the Russian 2010 heat wave, we see a quasi-stationary wave train with a hot, dry, high pressure system centered over western Russia, causing a month and a half of extremely hot temperatures, and a colder low pressure that sits over central Russia, and a warm high pressure over eastern Russia, and a cooler temperatures in the North Pacific. Randall Dole is an expert on blocking high pressure systems and concluded the 2010 Russian heat wave was mainly due to natural internal atmospheric variability that causes blocking high pressure systems in heat waves, seen in red, to form every few years in the region, while dry land surfaces amplified the 2010 heat. Hauser 2016 reported that dry soil moisture alone increased the risk of severe heat by 6-fold. Due to temperature contrast between the land and the ocean in the western USA mountain ranges, the Northeast Pacific is also a region where a wavy jet and blocking high pressure systems frequently form, bringing drought and heat waves to the western North America. Again, looking at temperature anomalies across North America, we see it is part of a wave train, with the hot blocking high-pressure system centered over Oregon, Washington, and Western Canada, a cool low-pressure system sitting over central USA and Canada, and warm high-pressure over Northeast America, and then cooler temperatures over the North Atlantic. The 45.5 degrees Celsius temperature in the town of Lytton, British Columbia, set a new record for Canada, but just barely, as the old Canadian record was 45 degrees flat, set in 1937. And although Oregon saw temperatures exceeding 40 degrees Celsius, it was still much cooler than Oregon's record heat of 48.3 Celsius set in 1898. Climate crisis narratives currently bombarding the public consistently ignore all the science in order to focus blame for heat waves on CO2 global warming. They ignore the hotter extremes in our cooler past. They ignore the high-pressure systems created by wave train dynamics. And climate crises narratives ignore high-pressure system dynamics of clearer skies and increased solar heating, of drier surfaces that raise the risk of heat waves six-fold or more, of adiabatic heating that warms temperatures without any added energy, and the narratives ignore the transport of warmer air into cooler regions. Attribution science is a newly created so-called science that appears to be just a rubber stamping of the climate crisis narratives, but their analyses never really account for all the contributing factors that good science must do. Instead, they prefer to push a meaningless statistic that a higher average temperature means more extreme weather. It is clearly misinformation. So up next, part 6, will be how pressure systems control growing and shrinking glaciers. Until then, embrace renowned scientist Thomas Huxley's advice that skepticism is the highest of duties and blind faith the one unpardonable sin. And if you appreciate the science clearly presented here, science that's rarely presented in mainstream media, then please give it a like, give it a share, or copy the video's URL and share it via email. Subscribe to my channel to easily find all my videos, or read my book, Landscapes and Cycles, An Environmentalist Journey to Climate Skepticism. Thank you.